Hello, welcome to another live stream. So we can see this better. So I spent a little bit of time off stream to try to get this working at 60 frames per second. And so I did a few things. We can go through. Well, first I fixed there is an error in the FIFO here that wasn't hooked up correctly, so I went and fixed that. And we'll start with the VDMA. So the VDMA, I increased the memory map data width. This is how much memory you can get over the read channel. What the bandwidth, try to increase the throughput to decrease the overhead of doing smaller bursts. Try to add a bigger line buffer. Another thing, we now have a pixel unpacker. And what this does, it takes a 32-bit and transfers it to 24-bit, allowing us to pack more data into the DDR so that we can hopefully get better bandwidth. And then we have that going to the device. And even though I've done all this, it is not working at 60 frames per second. It seems that the DDR bandwidth with the overhead that is in this system cannot meet the rate of doing 60 frames per second with VDMA. We're missing data. So what we're gonna do now is we're going to actually do 30 frames per second. So currently we have it at 148. So we're just going to 148.5 divided by 2, 74.25. So we're gonna go here and go 74.25. Okay. Now we're gonna save this and build the bit stream. Okay. I'm gonna go to the idle screen real quick so I can go turn off another a test I have in the background that's going to mess up our JTAG, and I'll just continue after the stream. Okay, we're back. So now we should have the JTAG chain. While this is running, let's open up the SDK and just kind of look at what I've done with the software-wise to get this running. So I think the goal here is we're going to try to get an image going. We're going to try to download an image, 1080p image. We'll use my logo I've been using for like the idle screen. So we'll probably have to do a Python OpenCV to create the binary data file. That will be fun. Let me see, do I have a hex? What's the hex file viewer? HXD. Yeah, the web HXD. I do have HXD. We'll use this to view the files. We'll have to view them. Vado SDK. Make this a much smaller window. We'll have to create kind of a file. So Let's go over this and why it's building, see if we can figure out how to do a Python file to load in an image. So first we're gonna put this. This is the this is our DVI timing. We put it into reset. So this is our frame. Our frame starts at this address. Each pixel is 3 bytes, and that's how many vertical lines we have. And this is the VDMA engine. VDMA off, VDMA on. Frame location. This is stride, which is basically equal to width in this situation. And this is the memory locations between the width. And since we're packing our data right next to each other, our stride is equal to our width. And this is our width. And it's the resolution 1920 and with by 3 bytes for each pixels. And then this is our height. And it's just reading some status. This is us configuring our timing, reading some more status, just sampling the frame. And then this is us drawing a white block, or black blocks in the white screen in the corner. So we're going to have this good. And as soon as this is done, oh, it's actually pretty far so far. Okay, so open up PowerShell. We have Python here. Exit. So let's make sure to first install OpenCV. So let's pipe install OpenCV. Pipe install OpenCV Python, right? So pip install OpenCV. Sure, why don't we just do that real quick? Okay, let's do open CV read image as RGB. So let's read an image, right? So we're gonna read an image. Image read, path to, color. So let's go to C and stream, and let's make a directory image proc cd image proc, and let's go ahead and take a background image. Here we go. I'm gonna put it in this folder. Rename back. Okay, so let's try doing this right here. So we're just going to do Python, just straight up. We're going to do import cv2. And we're going to do image equals cv2.image read. The file is just going to be back.jpg. And print image.shape. Oh, that's a big shape. So let's try to rescale the image. So open DV rescale image. So resize. So we're going to create a new image, right? We're going to say dimensions equal width is 1920 by 1080. And we want to do resized equal to CV2 resize image dimension. Boom. Okay. Now resized. Cool. So let's try CV2 dot image show test resized. Can you do that? Okay. Here's our image. We're good to go. So now we're just going to close the window. Okay. So now we need to print this into a file. So if I do resized, I just say 0, 0. We get the RGB. Well, let's convert. Let's see, image determine RGBR. Oh, we're going to open DV2. The image type is, then video will be displayed. If the image is created, then color will be displayed. Maybe we need to load the image as RGB. So let's see. So image CV2 image read RGB. Yeah. Image read. Select image. So yeah, let's do this. Let's resized and let us spec RGB. Okay. So we need to import or from import image. Pip install scale. Okay, so now let's write a binary file. Before we go anywhere, Python write binary file. Okay. Open a new file. So let's open a new file. So we have the file name, image, bin. So let's see, OpenCV write binary image. Not necessarily what I want. What's the PNG file format? PNG file format. Figure this out. Okay, now we just wanna figure out how to write a binary file. That's what we now have. The image RGB 0 0 0 0. There you go, RGB. Bitrate image RGB. Okay, so byte array equals new file byte, new file bytes. New file byte array equals that. Okay, so now if we look at this, right, we have 43, 57, 84. Let's open that file. Stream, image processing, image bin. So, And let's try something at the end, right? So this is 19, 19, and 1080. Oh, so this is going to be 1079, 1919. Okay. So, I mean, that looks like the image. We could do a quick check. View. Is there any way to view it in decimal? Quick. Can view. Coding, no. No, nothing real quick. So let's just go here real quick. Programming, decimal, 43 is 2B. Okay, so this would be RGB right here. So we save the file. That's cool. This has finished. So let's show what happens. So we're going to export the hardware. This is going to rebuild. Let's go ahead and just do a clean all. And program bit file. And the color is going to be off because we're only using a 12-bit color thing. That's what the DVI thing is available. I feel like we could have easily implemented a 24-bit one, but the way the pins are locked, that doesn't work. If we want to do something more sophisticated in the future, we should probably look at the pink FPGA or FPGA that's more dedicated DVI output. We do have I do have a lattice one that has a DVI output. Maybe we can look at that. Oh. What happens when you don't have it plugged in? Okay. Okay. So now we're going to take the other monitor, we're going to convert it to switch to HDMI so you can see a white screen with a black box. I guess I've messed around with it. It's now blue screen with black box. Blue screen with black box. Let me show you the wrong thing. Now you're going to see my okay, information. So only 30 frames per second, or yeah, 30 frames per second. We only got 30 hertz here. So let's see. Let's go back to this screen. So you can and let's bring this guy over here. So we're gonna CD to the stream folder. And we have image bin. So now we're gonna do DAO-data. We're gonna do this so you guys can see it happen. Right. DAO-data. We want to do DAO. We want to do image.bin-data. I think let me just do -help real quick. I can't remember exactly. So yeah, DAO data file address. So we're gonna do DAO data file, which is image.bin address 1234, which is the beginning of our target 4. Now if we go to targets, 4 is selected, and now we do that. And there it goes. There it goes. As we slowly write a huge image. What the colors we're expecting? Let's try it with the other image, right? So we try to convert it to RGB. Let's try resized. Oh. Yeah, we can have it to new file byte array. Let's open new file to image 2. And let's write that. Okay. Now let's go back to here. Try image 2 bin. Oh, that looks like the right colors. That was cool. Well, there you go. A 1080p image, 30 frames per second, outputted by the FPGA. I think that's pretty cool. And now we can try to do some image processing on these things. And it looks like the color is, I'll have to see. Oh, the way I have it set up. Yeah, it's blue, green, red right now. I don't know why. Maybe it's flipping it. I'm not sure what the VDMA is doing for, oh, the highest bit. Yeah, okay. So yeah, we can do this. This works out well. So what's happening is in the file, when we do the binary file right here, the highest bit is red. So this is red right here. Let me open up that image too. And we'll set this to 3. So the highest bit is red. The highest byte is red, green, and blue. So the first one was correct when we do the blue, green, red, because then when we convert it in the FPGA, we use the highest byte as red. Well, so I mean that was kind of the goal for this stream. Next week maybe we'll get a collection of some classic images, and then we can try to do some filtering on it. We can do HLS and then Verilog VHDL. And then we can try to scale it up and do some live time. I wanted to do 60 frames per second. The FPGA could do for 60 frames per second. The limitation is our DDR bandwidth. So we're just going to do it at 30 frames per second. And you could easily convert it to 60 frames per second. But doing it at 30 frames per second does give us a lot more ability, or give us a less demanding clock cycle. So we should be able to do we should be able to meet some higher demands. I'm probably going to lower some of the VRAM settings so we can use some of the VRAM for line buffers, and that way we can do some fun filtering. Yeah, we may add an Ethernet later. I'm not sure. We'll see how this goes. Yeah, I think this is where we'll end it today, and maybe let's go. Let me bring my stream controls to the other monitor. So let me bring stream controls over here. We can just do a large. There we go. And just let's just create a whole new scene. And we're gonna just call this droid cam. Okay, so now you can hear me. That's good. So while you can hear me, let me go add the webcam. Add video capture device. And we want the phone. So we're going to add this source. And we're going to make it the full screen so you guys can see it. Can I? No. Okay, so there we go. I think that's the note we're going to end on. I'll change it back real quick. I'll change it back so so we can see the color change real quick. We'll just do the color change because it's kind of fun to watch. So here's the first one where it's kind of the red and the blue are swapped. Just let that change real quick. And I'll switch back. And I think that's it for today. That was kind of fun. We resized the image, changed the image, and this is only running off 256 colors because we're only just doing 12-bit, right? No, 12-bit we have more than 256 colors. We have 2 to the 24th. 2 to the 14th. 2 to the 12th. I still don't know my things. We have 496 colors here. And this is what we can produce. If we had 24, if we had the full 24, we would have a lot more colors. That's, how many colors is that? That is 16 million colors. So we have 4,000 colors now. We could easily have 16 million colors. But yeah, so it looks like it did well. And that's where we're going to end the stream today. It was a short stream, but we achieved our goals quickly, didn't have any issues. We're doing 30 frames per second with a pixel unpacking. The pixel unpacking, let me change this over real quick. Oh no. So the pixel unpacking that I added from this thing, converting 32 to 24, allows us to get better bandwidth on our DDR, is from the Pink project. It's an HLS core. I built it for the ARTIX and placed it in. There's different modes you can pick. We're just doing a default mode. We have our DVI stream and our VDMA. Okay. And we basically just changed this, so we're now doing 30 frames per second. We could probably up it to some weird number like 40 frames, 45 frames, something like that. And still meet performance pretty well. But that's it. So, tomorrow, let's go do some simple image processing. We'll do probably inversion. Do inversion, maybe some sharpening, embossing. We could probably play around with something. I'll show you the stuff tomorrow. Okay, but that's it for today. Thank you for watching.